Hi, my name is Dan Burbank, and I'm a member of the Expedition 30 crew aboard the International Space Station.
And my name is André Kuipers. I'm a Dutch astronaut for the European Space Agency and also a member of the Expedition 30.
And I'm from the United States of America, NASA. We've got 15 nations that are all partners in the International Space Station program. We, Andre and I, have 4 additional crewmates that are on board station right now, busy doing science payloads. We wanted to take a few minutes just to talk to you a little bit about volume and how we manage storage of items aboard International Space Station. Space Station is about the size of a large 5-bedroom house, and we have a lot of equipment here. Some of the equipment keeps us healthy, keeps us strong, keeps us fed, generates oxygen for us to breathe, and some of the equipment, in fact quite a lot of the equipment, is science payloads, experiments and facilities where we ourselves have about 200 experiments that are to be conducted during the time we're here. To take care of those experiments, to take care of ourselves, we have a lot of logistics, a lot of supplies, a lot of equipment, and we store that in bags that are standard size. We have some bags that are small, we have some bags that are medium, we have some bags that are large, and we have some bags that are very, very large. But even beyond that, we have some bags that are downright huge. We could fit some crew members in this bag, in fact. Now, the things that all these bags here that we just showed you have in common is they have perpendicular sides and they can be measured, the volume can be measured by the simple equation length times width times height. And we standardize those. And the bags that I showed you earlier are fractions of each other. So one bag is half the size of another, which is half the size of another still, and so on. Now, knowing about the volume that something has isn't the whole story. In space, we like to say that everything is weightless, and by that, really what we're saying is that the force of gravity that would ordinarily be acting on us if we were standing on planet Earth, for example, is counteracted by the orbital motion, the high velocity that the International Space Station and anything in low Earth orbit has to travel. So we could look at anything, whether it's massive or whether it is it has a very small quantity of mass, and they would behave exactly the same. You could float them here, and it would be very difficult if they were not moving relative to their surroundings to identify which had more mass and which had less. And in this case, these are both in half CTBs, both the same volume. This half CTB has very light items in it, and lightweight items, I guess we would say, and these are Ziploc bags. So this is not very massive. This CTB, however, has water in it, a large quantity of water, and it is, in comparison, quite massive. And again, both of them we like to say are weightless. But we have to be very careful when we handle massive objects in space, because massive objects carry inertia. If massive objects move fast, move quickly relative to their surroundings, they can do damage or potentially hurt a crew member. So to demonstrate the difference between a massive object and a light object in the weightlessness of space, Andre is going to hold this bag and he's going to shake it back and forth, and you can see how much effect that has on his body as he moves it. Not very much. The bag moves a lot, he moves a little. In contrast to that, here's a massive bag. This is the one that's filled with water. Andre is going to do the same thing, and he's going to move it back and forth. Now watch how much his body moved compared to the bag or compared to how it did last time. So we can, on space station, carry very, very heavy things around with us. We can be outside in a spacewalk and carry very massive things, but we have to be very careful when we do it. If you were to impart an impulse, that is a short duration force, to both of these objects, they're going to behave very, very differently. So he's going to push with the same amount of effort with both ones, and you can see how quickly the not so massive bag will accelerate relative to the other one.
Now, if you put energy into an object and the object gets into contact with another object, the energy goes to the other object. It's like playing pool. The same thing with the pool balls will also happen with weightless object. So if a bag is thrown at me, then it's very depending on the mass what will happen.
So the not so massive bag has very little effect on Andre. On the other hand, if I take the water-filled, more massive bag and I toss it to Andre, it's a very different result.
It's very nice to demonstrate to you the difference between volume and mass and weight, and how we deal with that every day here in the International Space Station with all the CTBs, the cargo bags that we have on board. My name is Andre Kuipers from the European Space Agency, signing off.
And I'm Dan Burbank from NASA. Best wishes.